So in this video, I will be covering the derivative and integral of the number e. Now to begin, one fundamental theorem or part of calculus that we understand is that the derivative of e to the x is e to the x itself. Now to understand how we derive this, what we first know is that of uh, the derivative of e to the x is equal to m of e multiplied by e to the x. And this pertains to really any function with or to any base to the power of x. It will equal the derivative of any base to the power of x will equal the m of that base times the base to the x. So now this stands when m of e is equal to the limit of h approaching 0 of e to the h minus 1 all over h. And now it just so happens that this limit itself is equal to 1. And as such, we can then derive the derivative of e to the x as d dx of e to the x will equal 1 times e to the x, meaning that the derivative of e to the x is e to the x itself. So a fact that we know is that the derivative of e to the x is equal to e to the x. And now, once again, based off of that, we discovered that the integral of e to the x will always be equal to e to the x plus c. So now, if we look at some examples for both the derivative of e to the x and the integral of e to the x, we'll be able to solve them based on what we discovered earlier. So now, as stated prior, the derivative of e to the x is e to the x itself. However, we must now find out what we will do if it is e to the power of something greater than simply x itself. So now in this case, essentially what we have to do is we essentially have to apply a chain rule so our f of x would be equal to our e to the x, or our base. Our g of x would be, in this case, negative 9x, which means our derivative of f of x, as stated prior, the derivative of e to the x is e to the x itself, and the derivative of our g to the x would simply be negative 9. So now what we have to do in this scenario is we have to apply the chain rule. So now, according to the chain rule, we take our derivative of f of x in this case. So that will give us e to the x. But we must plug in our g of x for our x value. So then that then turns into e to the negative 9x. And now we must multiply this value. We must multiply this value by our derivative g of x, which is negative 9. So in this case, what we will discover is our derivative of e to the negative 9x should result in us getting e to the negative 9x multiplied by our g prime of x, which is negative 9, which will then result in our derivative equaling negative 9 e to the negative 9x. So that will be our derivative of e to the negative 9x. Now, if we move on to a second example, we can begin to examine the properties of e to the x when doing integration. So in this case, for our example, we will take the integral of e to the 7x dx and find out or discover what that equals. So now, in this case, we won't be using chain rule or anything of the sort because it's not really a derivative, but what we have to do is u substitution. So in this case, our u value is equal to 7x, which means that our du value is equal to 7 dx. Now, because there isn't a 7 dx in the function, but there's a dx, we will divide this side out by 7 and this side out by 7 in order to get our to be able to plug in our u and du for our function. So now what we will get it equal to is we will get it equal to the integral of e to the u times du over 7, which equals 1 over 7 times the integral of e to the u du. Now, as stated prior, the integral of e to the u du, or rather e to the x dx, will always be equal to e to the x plus c. So in this case, we will get our integral with our u substitution is equal to 1 over 7 times e to the u plus c. And in this case, because our u is equal to 7x, our final value for our integration will be 1 over 7 times e to the 7x plus c.